I'm excited about changing the way the world powers its future, proving that difficult challenges can still be solved and manufactured in the United States. And as a result of those two things, creating green tech careers for people to grow themselves in the future.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome to another edition of the Insider's Guide to Energy podcast. I'm your host, Chris Sass, and with me is my co-host, Jeff McAulay. Jeff, what are we talking about today?
Chris, today's topic is long-duration energy storage. And we're joined by Joe Mastrangelo, the CEO of EOS Energy Storage, that is producing a zinc-based chemistry. Joe, welcome to the show.
Thanks, Jeff. Thanks, Chris. Great to be here.
So I think we have to start off with, what is long-duration energy storage?
Yeah, so that's a great question because a lot of people define it a lot of different ways. For us, it's anything from 3 to 12 hours and being extremely flexible around that time frame. And being able to deliver, multiple cycles, if you will, within that time frame. So it's not really thinking about discharging over that entire amount, but doing multiple cycles without degrading your battery or reducing performance.
For exotic iron or sodium-based, there's even more flow battery designs. Right. How do you orient the zinc-based chemistry that you're working on, the design, within that range of other chemistries?
Yeah, so we call it, it a hybrid technology, and hybrid in the fact that, we're a static battery. So if you look over my shoulder there, you see a white square and a gray square. The gray square is the current design of the battery. It's self-contained, aqueous water-based electrolyte that, like flow batteries, you wouldn't, you have abundant raw materials. We don't use a pump system like a flow battery would use, and unlike lithium ion, we don't use any fire suppression because the battery is inherently non-flammable.
Wonderful. And that's the supply side. Tell us about the demand side. You talked about fluctuating demand on the grid. And for insiders listening, they know that could be anything from behind the meter demand charge management to demand response to frequency regulation. So especially as you get into the longer durations, what are the applications you're targeting, and help us understand if that's mostly behind the meter or front of the meter applications?
So it's a mix of both. When you look at that, the way the company started, the inventor by the name of Steve Amendola, he had a solar panel company that went out of business when Chinese entered the market in the U.S. But he looked at solar and said, what solar really needs is an energy storage system that could be a minimum of 4 hours to make it a base load technology. So he was onto the intermittency and having longer duration energy storage, 16 years ago when EOS was founded. As we moved forward and through the development of the product, we started looking at how can we meet the demands in the market. And if I look at, I've been with EOS for the last 6 years, those demands have evolved over time. Like when I first got here, we were talking about minutes, and we started talking about a couple hours, and we started talking about 4 hours. And now people are starting to look at this 8 to 12 hour range, which is where our technology fits in. So less so on, specific applications, and more so like when we think about use cases of how customers use the technology for those discharge times. So we've mostly been going after utility scale and large developer projects, and that's been more because of the size of the company. Now, when we start looking at applications that we can address, we're also looking at going after industrial applications, commercial applications that require smaller systems, are more dispersed now that we have the capital to be able to grow the business.
Is there a lot of pent-up demand then for storage? I mean, everything we've talked about, I've been doing this podcast now for 4.5 years, and we always talk about storage and when we have storage. And well, you said about the size of the company and who you're targeting. Is it like easy hunting? Is there just so much pent-up demand that's there? Or is it just that sweet spot of that 8 hours, that number of hours? Does that limit the market quite a bit?
So, Chris, I think there's a lot that goes into that question. So I think there is a pent-up demand, but there's a pent-up demand surrounded by a couple facts when you think about how the industry works, right? Fact number one is it's not easy to get approvals to bring projects online. So that's one thing that kind of hampers the demand as you kind of go through the process of getting projects approved. Fact number two, when you look at the market, is showing that that you have a proven technology that's going to work. Like I always say, in the energy industry, everybody wants to be the first person to be second to bringing on technology. So it's how do you build up the references for your technology? And when you look at where we are, we've now discharged more than 4 gigawatt hours of energy out in the field with our technology. So we're starting to get up to that point where you get bankability, you have proven hours of operation. Now you're up against kind of the process of getting things approved and getting onto the grid. That's why when you look at where we've gone into markets where it was faster to get on the grid. Places like Texas, we've done some stuff in the Southeast United States. That's where you start looking at the developer market versus utility market, or selling directly into utilities, because they will move faster and take that technology risk. So the demand is absolutely there. There's a process of bringing your product online and proving out that it can work, which holds true for every technology that you have in the industry.
And Joe, you're selling to a system integrator who might be selling to a developer. So how closely tied are you to the application of, let's say, Texas merchant battery value stacking? Is that very tightly coupled, or are you really providing an asset and then it's up to the customer how they run it?
No, so I think, Jeff, you bring up, this is a great point. A lot of our sale process of bringing the product to the market is actually sitting down and going through the use case with the customer and understanding how not only our technology meets the use case, but at the same time, how the technology can enhance the use case. So showing people the flexibility and how the technology works, how that creates additional revenue streams for the technology as you move forward. So a lot of the work that we do is we take what the customer wants to do, and then we do an analysis of where they want to install it, marry those two things up with one another, and then show them the unique operating parameters that we have in our technology. Things like I talked earlier, running multiple cycles in a day, running what we call mini cycles, where you're charging and discharging throughout the day to do peak shaving, but not doing it as you think of it as a single use case within the day. I mean, you've got to explain that to people. And then at the same time, we bring them to our test facility in Edison, New Jersey, and show them the technology actually running on those use cases.
And in those examples, let's stick with the grid-tied front-of-the-meter application. What are the metrics that matter? Is it round-trip efficiency? Is it depth of discharge? Is it cycle life? Is it duration? What are the things that really matter for that application?
Yeah, so you where you wind up is all those things play into a levelized cost of storage calculation, and what we try to do with our technology is also show things that aren't in that levelized cost of storage. So yes, what we try to show people is round trip efficiency is important, but net round trip efficiency is what the cost is to the project. So a lot of times when you hear round trip efficiency numbers, you're talking about round trip efficiency before the losses associated with running the pumping system if you're doing a flow battery, or running the HVAC if you're running a lithium ion system. So we try to show like we have very low losses. Like if you look at an individual cube or container that we would sell, the amount of energy that we consume to keep that running is equivalent to a couple of light bulbs in your home, much less than what everyone else does, but not included in today's levelized cost of storage. At the same time, look, we provide a lower round trip efficiency, but a wider operating range, a wider depth of discharge, and then also like to show people that our battery can sit at zero charge and nothing happens to it. So you can leave the system sitting at zero for months, come back, charge it, and the system will run again. There's value in that depending on the use case that you're being able to use. Whereas with other technologies, you're going to wind up damaging your system if you do that.
That's an interesting point on the parasitics as well. I wish levelized cost of storage was an easier concept for me. I feel like I'm, spoiled on LCOE in solar, which you just compare to the grid. So, is that a easy metric to use? And if I could maybe propose another one, which is just peaker parity, right? At what point can you have a battery system that displaces a natural gas peaker? What do you think of that metric? Are we close to that point? Is there a tipping point here when batteries just literally replace peakers in large sections of the market?
I think you're seeing that shift in places like California today? And I think the answer is, yes, you can get to that point where this, as you call peaker parity, where, when you look at how our energy system is designed, right? It's all designed to handle peak load and have margin on your peak load. So you've got way more than you need at the peak, but it's never available at one period of time. So then you wind up with, the peaker gas plants, offsetting that. If you're able to take energy and store it when there's curtailing, right? So I think, when you talk about peaker, you got to talk about the flip side of that, which is the curtailment side, which is huge when you think about the amount of capacity that's wasted because there's not demand for it to be produced at a certain point in time. If storage comes in and marries up that peak demand with that curtailment moment, now all of a sudden you're at parity, but a different type of parity, right? You got to think about it differently because you got to think about the opportunity cost of what you're capturing on not curtailing renewables, saving that and using it when you would have used another asset to be able to do that. So we don't have the right metric today to be able to do that and capture that. And that's, I think, part of the reason why you don't see this. You see the pent up demand in the projects, but you don't see the projects closing. Is getting people to understand how the actual process works, tied into the economics and what the benefits are overall for the system to be able to do that.
And when I think of storage and you talk about that whole ecosystem there, I guess domestic content is something that comes to mind. Right. And you talked about a zinc chemistry. Batteries, if you listen to the world, everyone's thinking horrible things because everyone else thinks we're so far behind in battery technology. To do this kind of storage, what does the supply chain look like?
Yeah, it's a great question, Chris. I look at my career where I spent the first 26 years of my career in a very global business, putting factories around the world in places like China. Come to EOS 6 years ago, less than 50 people, pre-revenue, and trying to, at the time, the strategy was to put a supply chain in China, and it was a hybrid supply chain, like building dry batteries, bringing them to the US, filling them, shipping to customers. Economically prohibitive, and also didn't have the manpower to be able to do that. So we brought everything back to the US and said, we're going to do this in a way where, we were kind of forced by the economics of the company to say, we're going to do this in a way where you can get in your car and drive to your suppliers. So we went out and found people with capability in other industries to help us develop the technology and the supply chain for the company. It's what saved EOS during COVID, right? If we hadn't done that pre-COVID, there's no way we would have been able to survive through COVID, given the way the world shut down, particularly when you look at going in and out of China at that period of time. From there, we just started building up capability supplier by supplier to where today, more than 90% of our supply chain is US based. Our factory in and of itself is based in Turtle Creek, Pennsylvania, where Westinghouse was started. We're moving into the Mon Valley where manufacturing has been leaving the Mon Valley since the late 70s, early 80s. Coming back in, we went from 2 employees in 2019 to over 300 employees today. We put in an automated line, which was made in Wisconsin. We can still build things in the United States. We can still lead on technology, and also simplifies the supply chain and gives you that security of being able to supply the battery, but also that security of what you're putting on the grid has American-made components in it.
It's really inspiring, Joe, and it's been a long journey. You said 16 years since founding. We're going to get into some of that. Part of that long history and experience is about building confidence in the brand, building confidence in deployments, bankability in the eyes of project financiers. What have been some of the most important lessons in that journey? And in particular, does it just take time? Does it just take being around for 16 years? Or are there ways, if you look back, that you think that could have been accelerated?
Yeah, I always think of the company and that we've gone through 3 5-year phases, right? So phase 1 was proving that you can get the technology to work, lab cells. Phase 2 was thinking about how you take a lab cell and get a product. And then phase 3, the last 5 years, is how can you scale that for costs and economies of scale. Each one of those are extremely challenging. What I always tell people is, when you get the clean sheet of paper to build something, there's a lot you got to build around that besides a product. So it does take a while to do this. it does, particularly in the battery space, when you look at what's happening with other companies out there, there's peaks and valleys to how you get through this, and you don't learn until you actually get to that point in time. Now, what we tried to do early on was we had a couple core philosophies that we went after. So what we said was every raw material that goes into our system has to be used somewhere else in the world, in another industry at scale. So we weren't out creating supply chain and creating materials for EOS. We were using what other people were using in our battery using our technology. The second piece was we said, we're not going to build a massive gigafactory, because if we get it wrong, we're going to bankrupt ourselves, because if it doesn't work, you're going to wind up that you're not going to have the money to fix it. So what we said was, first learn how to do your individual manufacturing processes, then do semi-automated line. And semi-automated meaning that you change your material flow around to figure out how you want to lay your line out, then do a state-of-the-art automated manufacturing line. Doing those two guiding principles kind of allowed us to get through the other side. And then the third piece was, looked at the energy industry and the experience that a lot of us have in it and said, this has got to be something that's simple, without a lot of ancillary systems around. It has to be easy to operate. We took those three things, we wound up with something that got us to the point where we're scaling and producing energy out in the field, where I think others in the past have had struggles to be able to do this. So this is not easy. And I always tell people, probably the hardest thing I've ever done in my career was what we're doing right now as a team at EOS.
So I like the concept that you found other industries and used readily available materials. I worked at a startup once where we didn't do that, and that was very cost prohibitive until you get to the economies of scale needed. So that was pretty interesting. But there is a perception that lithium batteries are ruling the world today, and we're talking about a different technology here. Maybe help me understand a bit about the advantages and disadvantages of zinc over lithium.
Yeah, so I think what we're talking about is, there's things where lithium is the right application, and I always draw parallels of, there's always going to be a mix in the energy industry. When you look at what we're talking about, this wanting to have a system that can handle variation, that has multiple ways to operate, that gives you the flexibility on use cases, is non-flammable, made in the USA. When we talk to people, you always wind up with two types of discussions, right? Everybody looks at what you're trying to do and says, wow, that's a really steep ramp you're trying to get through. That's going to be hard. And there's other people that look at it and say, yeah, but you're going to do all that and still only have 3% of the market. I thought this was a great technology, but that 3% of a market is a couple $1 billion company, right? So I think, like, as I've thought about this, is there's plenty of use cases out there. We don't feel like we compete directly against lithium ion. We're complementary to one another and to what we need to do. And we don't look at this and say, hey, if you want to do 2-hour discharge every day, use EOS. We're not the right technology for that. But when somebody comes and says, some days I'm going to want to charge for 2 hours, I'm going to want to charge for 7, I'm going to discharge for 7, I want to discharge for 2, we've got that technology that meets that need. If you're going into an area where non-flammability is important, we meet that need. If you're going into an area where you need it to be quiet because we don't have any ancillary systems, our systems sound, they make the same amount of noise that we're making talking to one another today. So between the safety, the silence, and the flexibility, you've got something that other people can't do, and there are use cases for that.
And how does it economically stack up against alternative choices?
Yeah, well, so Chris, if you go back to this concept of take what's already being used in other industries, your cost curve comes down relatively rapidly as you scale the company. And when you look at it from a material cost standpoint, we feel like we're very competitive against any other technology out there. What we need to do right now is scale into the overhead of our facility to take the total cost down and make the company profitable. And that's what we've been working on here for the last year as we bring on the state-of-the-art line.
Joe, you've got a tremendous amount of perspective coming in here. So we got to talk about how you arrived at this perspective, because it seems obvious when you say it, but yet there's a lot of companies out there who are not necessarily heeding these lessons. The staged growth approach, the supply chain management, really going hard on onshore. Those are all, I think, stories that we don't hear nearly enough. Tell us about your personal professional journey and how you arrived at some of those insights.
Yeah, so I started at General Electric, now it's 32 years ago, hard to believe. And started off in the energy business, in the power business in Schenectady, New York. I'm a finance person by background. I went to work in the oil and gas. I spent 7 years working in finance across GE. Went to Europe to work for GE's oil and gas business. So I was involved in the ramp up of LNG, offshore oil and gas. Started when oil prices were in the teens and went through to where everybody was talking about $200 a barrel of oil. Then led the integration of electrical systems business, and my last job was leading the gas power systems business for GE. So when I came into the job, I had this tremendous amount of experience. Was blessed with being able to work across the world with large teams, and really saw things from going after challenges and opportunities with a lot of scale behind you, and had to come in and say, I've got to think about everything in reverse in what we're doing at EOS, and really think about what if you don't have the resources to do things? What if you don't have the funding to be able to do this? Like what I always say is, what I learned at EOS was like, if you're faced with a challenge at GE, you look at that and you say, well, let's look at the three alternatives and move those forward and give each a little bit of money till one emerges as what we're going to work on. At EOS, you had to pick the one because that's all you could do. So you became much better at capital allocation than you would be in a big company. But then also, if you go back to like, Jeff, what you brought up in your comment around bringing back the manufacturing from China and bringing it to the United States, I knew what it took to set a factory up, internationally. I knew the amount of work, I knew the support. These things don't happen overnight. You don't just turn it over and somebody manufactures a new product for you without you being involved in doing this. And you have to know how hard that is. And really what I looked at it as is realistically what it came down to was like, we couldn't afford the plane tickets to send people to China to watch the partner work on this. So it was like, what are you going to spend your money on? And that's ultimately how we started doing it. And it's turned into a strategic advantage for the company. But all that kind of catalog of experiences and seeing things grow, like I always say, like I've been through 3 nuclear renaissances in my career. I've seen that come and go. I've seen a lot of things that we're talking about today come and go. So you kind of have to look at it and think about like what's going to make something successful is you have a demand for it, it's easy to use, it has a competitive cost, and it meets a use case that customers want. And that's how we kind of tried to focus EOS over the last 6 years.
You highlighted some of the benefits and drawbacks of the capitalization of the company. So in GE, you don't have to worry about raising external money, but maybe the fact that you do makes you scrappy and really thoughtful in how you make those decisions. Can you talk about how the capitalization of EOS has progressed and how you've been able to raise money? Because honestly, for companies in this space, just surviving is a big part of the battle.
Yeah, I mean, we went public 4 years ago on the NASDAQ through a SPAC. It's been a journey to be able to kind of work our way through that. Like when you look, I talked about the challenges in COVID, right? Then what came out of COVID was high inflation, right? So there was a period of time where our entire plan for the company became challenged just because what was a very cheap item in our bill of material became very expensive. And how do you offset that? And how do you bring that and make it domestic? Raising capital, going through and kind of doing it of progress and move the ball forward. Like what I always said was when the mindset shift I had to have as a leader here was less about deliver your target to more, all right, given the capital that we have, what progress can we make? That kind of changed for us back in January where, Cerberus came in with a large investment in the company through their strategic supply chain fund, where now you have the backing and the network to be able to position the company strategically to grow, where up until that time, we were in a fight for survival to prove that we can actually build this product. And really what got people through this was understanding the talent of the team that we have and also being able to come here in Turtle Creek and see us manufacturing batteries and saying, okay, I get it. They're right. It's simple. It can be done.
So Joe, take a take a ride in a time machine with us 5 years in the future. You mentioned those kind of 3-5 year chunks. We're chatting again over a coffee or a beer 5 years from now, and you're like, Jeff, this was the fourth 5 year chunk.
Yeah, I mean, now it's really about becoming, operational excellence. So like the place where, we've struggled as a company has been, hitting our targets, right? So I think this next phase of our development is going to be delivering on expectations, but not just delivering on expectations to shareholders, but also to customers, right? So I think there's a huge need in the industry. It's like everybody thinks, like when you say energy storage batteries, right? We all think it's easy. We think it's like clipping that battery into your remote control and away we go. It's pretty complex when you think about what you're trying to do and the integration, the software integration, electrical system integration, and how it operates. So like we want to be world class in that area and how we do that, and then become the company of choice to be the partner to have the best uptime and availability product out in the marketplace. And then we'll see where that goes from there and where you can build out around that. But like the strategy of the company, it's always been a differentiated battery technology at its core, a very simple system design, proprietary battery management system, and now getting into total energy storage systems excellence. Because like when I first came in, where I was wrong was I thought, look, we just have to build a DC system and plug that into whatever the end user wants to use. Like we're too small to dictate what somebody's going to use as their energy management system or their inverter or transformer. But many customers are asking for that design and execution. We've got to build that capability and become world class around that.
So I think you helped. What was coming to my mind is, you talked about the financing, you talked a bit about the vision of where you need to go, but scaling's hard, right?
Yeah.
That is the hard thing. You talked about manufacturing, onshore, offshore, and all the economic trade-offs. So with funding and that excellence, talk a little bit more about the scaling. I mean, you built a plant, but you have to have pipeline to get the cost down. Per unit cost needs to drop down. How do you go to a market that doesn't usually have early movers that aren't excited to be first, or maybe it's developers that are okay being first, but then they're looking at bankability and is this really a credible solution that has the availability to put funds in?
Yeah.
How are you scaling this up?
So when you look at so Chris, that like let's put aside. I've talked a lot about the operational scaling of this. On the commercial side, we're building up, being able to provide insurance, because there's always the question around, the question that's gone away with the Cerberus investment is EOS going to be here, right? So I think everybody now understands EOS will be here. When we're talking to customers, we explain to them now the backing that we have and the investment that we have. Then it's really coming in and saying, what do you need from a warranty standpoint or insurance standpoint to prove out the technology? And then again, it goes back to like, you got to work each project individually to get through that bankability question. And it's different for every customer. It's different for every application. It's different. And a lot of times, like we're in the midst of getting ready to execute on what some of our customers are calling pilot projects, but these pilot projects are 50 megawatt hour projects. So these are not small projects, right? That then proves that you can do something at scale. And once you can do something at scale, you got to earn that right to grow. And that's where we are right now in that continuum. And I think part of why, going back to like Jeff's earlier question around demand and when do we see this with all this demand, where's the growth? I think that's the process that everybody has to work through to get to that point where people come and see and say, okay, I know, like what I always tell my team is when a customer places a purchase order with us, they're kind of betting their career a little bit on our ability to deliver, and we need to be able to deliver. When somebody wants to bet their career, it's going to take a while to get through and get everybody comfortable with what we want to do. But every day we have people coming to the facility that come and see the product coming off the line. We walk them to another building and show them product that's operating as we're doing factory acceptance testing, and they see that it works, and that helps us overcome those hurdles.
Joe, for the listeners who might be early in their career, they're graduating they're excited about energy and sustainability. They want to do something. They may be coming from a tech sector and have a set of skills and want to apply it. They're coming apply that. They're coming from the finance. What advice would you have, given that we have a wide range of listeners, for people who want to be more active in the space?
Look, I think it's an exciting time to be in the space. And if when I look back when my career started, I wasn't sitting in college saying, I really want a career in energy. Like, that wasn't what I was thinking. Like, I got a job with a big company that said, yeah, well, we're going to move you around. You have all these opportunities. And I went to Schenectady. And then what I learned is how fascinating this industry really is, right? So, Jeff, you've touched on every project has this element of strategy behind it, where you're mixing this technology to a use case with financing, putting pieces of the puzzle together, then having to deliver it and get it operating. It's exciting around that. And then at the same time, the fundamental secular shift that's happening, we are at this period of time going to change the way the world powers its future. So if you're sitting there and your example of you're a software person, like, we're scratching the surface of what software, artificial intelligence can do in this industry, machine learning to make assets better. I mean, it's pretty exciting to be able to do this, right? So when I think about where I started, I was so naive and thinking about how much power do you put on, this 32 years ago, how many gas turbines are you building every year? Little did I know how much it was and how exciting it is and how you have to put all these pieces together. So it's pretty exciting to be able to do this. And I think if early in my career, what I would always say is, come in and learn, and you're going to find an industry that is, if you want to change the future of the world and the way the world powers itself and help the environment, you get that here. If you want to come in and prove out that, like when you look in the U.S. right now, that we can still manufacture in the U.S., you can get that in the industry right now. And if you want to look and say, like, hey, I'm giving people and creating an opportunity for careers for people, that's also part of what you're doing. I mean, that's kind of the three-pronged value proposition that I think about as you look at a job at EOS, of doing those three things. And I add on top of it of doing something that's very difficult to be done. So if you're that type of person who has belief in themselves that they can do things that no one's ever done before, this is a great industry to come in and show how good you are. That's
an inspiring vision, Joe. Thank you for being a guide through so many different topics: the technology, the financing, the market, the career development. This was a really fantastic conversation. Really appreciate you. Thank you.
Thank you. Thanks for the time.
What a fun episode this has been, finding about manufacturing onshore, zinc batteries. It's great. If you like this content, don't forget to comment. Don't forget to subscribe to us and invite your friends to share the comments. We enjoyed this episode. Thank you so much for being our guest, and we'll see you again next time on the Insider's Guide to Energy. Bye for now.